Alright, so we are going to continue 7.1 today, which is just working with monomials, polynomials, finding the sum and the difference. We'll be starting 7.2 tomorrow, on Friday, the 10th. So, we talked a little bit about adding polynomials at the end of class last time, but in case you forgot, it's just an exercise in combining like terms. So what I'm going to do here visually is just circle my like terms in the same corresponding colors. But it's really just about, can you add things that are like terms? Alright, so starting with the orange like terms, I have negative 3p cubed and negative p cubed. When I add those two together, what do I end up with? Yep, negative 4p cubed. Moving on to the pink terms, I have 5p squared and negative 8p squared. When I add those, what do I get?
Negative 3p squared.
Yep. So minus 3p squared. And then I have negative 2p and negative 15p. When I add those, what do I get? Negative 17p. I check and make sure that this is in standard form. Is it?
Yeah.
Yes, because how do I know it's in standard form? Yeah, the exponents are in order from greatest to least. Perfect. Now, I want to classify this based on the number of terms. So what is this called? A trinomial. Yep. Remember the nomial stuff? Trinomial, binomial, that is classifying it based on the number of terms. This is a polynomial of degree what? 3. Yes, because the highest exponent is 3. And is this linear, quadratic, or cubic? Cubic. Great. Same thing here. I'm not going to color code it because I assume you know what to do. So what do I end up with when I combine my like terms?
12r squared.
Yep. 12r squared, because I combine the 9r squared and the 3r squared, plus r, 4r, and the minus 3r, and then minus 7. Perfect. Again, a trinomial. This is of degree 2, and it's a quadratic expression. Remember, it's an expression because we don't have an equal sign. We don't say equation unless we have an equal sign. Any questions on the bell word? Alright, we're just going to look at subtraction. Let me plug in my computer. Alright, so we're going to look at subtracting polynomials. Really, this is just, do you remember the negative sign? What I like to do is I like to turn my subtraction sign into an addition sign and then just change all the signs. So this becomes a plus, this becomes a minus, this becomes a plus. It's just adding again. So 4n squared plus 2n squared is 6n squared. And then I have, what comes next? Yeah, is it minus 2n or plus 2n? Minus 2n. Remember, I had to change that sign. And then, what do I end with? Well, 5 and 4 is 9, right? Yeah. Alright. So, any questions about that? Yes.
If you're doing it with the vertical form, does it matter which equation you put under the vertical?
That's a great question. Great question. It doesn't. So if I did the vertical form, that means just stacking them one on top of the other. What you want to do is you want to make sure that you represent all of the terms. So I don't have an n for the first one, right? So I want to put just plus 0n. And then plus 5. And then when I want to subtract that from negative 2n squared plus 2n minus 4. And you can do it that way. So the important thing is just to remember to replace that middle term with a 0 and whatever. And that is very helpful, like I said, because as far as things being represented, you will need to know what variables are represented and not represented in the future. Okay. Trinomial, quadratic, of degree 2. Yes.
How come you didn't change the sign to minus?
Well, because it doesn't follow the subtraction sign. Remember, if you're subtracting, the subtraction sign gets distributed to every term. So that's why I had to change it to the opposite sign. So when I have a minus here, and I distribute that, because that's like a -1, right, in front of it? When I distribute that -1 to the first term, that becomes a positive, that becomes a negative, that becomes a positive. Yeah. So because that 5 is in front, it's not affected. Any other questions? These are all good. Again, for the next one, I like to work with addition because it's easier. So I change that to addition, but I have to change that to a minus, that to a plus, that to a plus. Okay, so what do I end up with on B? What's my first term?
Instead of 1x squared.
Yeah, it's just x squared, yeah. 1x squared is just x squared. Yeah, try to get out of the habit of putting 1x squared because we want to just recognize that that is an implied one, just leave it x squared. And then, what do we have next?
Minus 2x.
Minus 2x. And then what do we have next? Plus 13. Yep. Okay, so this is a what? Trinomial of degree 2, and what kind of function?
Quadratic.
Yeah, a quadratic expression. Yep, good. That's pretty much it with adding and subtracting. Do you have any questions about that? Yes. Trinomial is, so that's based on the number of terms that we have. So I have 1 term, 2 terms, 3 terms. Each of these monomials is counted separately as an individual term. Yeah? So each of these monomials make my polynomial. Does that make sense? So monomial 1, monomial 2, monomial 3 make this a trinomial. So 3 monomials. Yeah? Great questions. We're going to look at a word problem. Oh gosh, did I get any of the last slide? Well, here's the last slide. I just change all these minus signs to plus signs, and then I change the sign accordingly. And then I just add. So really when I'm subtracting, I'm just adding and then putting all the opposite signs. Okay. Alright, if I start talking and then I have a pause, let me know. Because I don't want to miss the good discussion here. Now, if you are watching this video and you want to pause it now and practice these, you can. And I will unveil these answers so that you can check right now. Remember to put everything in standard form. All right. We are going to take a look at example 6, which is a word problem. It can be pretty confusing, but this is really what I want to move us towards, is being able to understand problems like this. And I attended a training a couple days ago, and it just dawned on me, like this light bulb went off in my head about the way I'm teaching math and the way I should be teaching it. And one of the things that I recognized in that training was that your book often does a good job of kind of splitting things up, like, okay, these are the easy problems, these are the problems with a little bit more symbolic language, these are the graphing problems, but it doesn't do a really good job of putting it all together. And then when you have a word problem on a test where you have to put it all together, it's no wonder that a lot of people struggle, right? So I really need to do a better job, and I will try to do a better job of having us work more with putting everything together so it's more of a norm for us, so it's more normal, so that you're not like, whoa, I only saw these things separately, and now all of a sudden I have to put it together in one problem. So, yeah, one of those light bulb moments as a teacher. So, we're going to throw a penny straight down from a building. A penny is thrown straight down from a height of 200 feet. At the same time, a paintbrush is dropped from a height of 100 feet. By the way, because of mass, which one is going to land first? Say what? They're not going to hit the ground at the same time. We don't exist in a vacuum. The paintbrush, right? Because it has more mass. Now in a vacuum, if we didn't take into account air resistance, right? Then they would literally hit the ground at the exact same time. They did and I'll try to find the video, an experiment with a bowling ball and feathers. And they dropped those two. Have you seen that video before? And then they landed at the exact same time. So they're the same thing. So here we're taking into account air resistance. So we want to know, first of all, a polynomial that represents the distance between the penny and the paintbrush after t seconds. So first of all, I have to think to myself, what the heck do these polynomials mean? This is, the second guy is dropping a paintbrush.
The first guy.
That's not a penny. That's the biggest penny I've ever seen in my life. Yeah.
And the second guy's throwing out a balloon.
That is very true. That's the biggest penny I've ever seen. And the biggest paintbrush I've ever seen. So, obviously, not drawn to scale. Means something. Okay, so what does the first polynomial represent? Yeah, but what of the penny? Not how fast, not the mass, not the time. The polynomials represent the heights. So again, read your word problem. In feet of the objects after t seconds. So this is the height of the penny. The first one is the height of the penny. Height of penny or frisbee or whatever. Flying soft. After t seconds. And this is the height of the paintbrush or broom or whatever. Okay. We're good with that. Now, our task is to write a polynomial that represents the distance between the penny and the paintbrush. How can I find the distance in between them? Subtract them. Right. If I want to find the distance in between both of those heights, I'm going to have to subtract. So let's say after t seconds something is 4 feet from its initial starting point, the other's 3 feet, the distance between them would be 1. Right? So I have to subtract. So that's what I'm going to do. I'm going to subtract those polynomials. So negative 16t squared minus 40t plus 200. And then minus. And I'm going to put a parentheses, so I remember, that's not a parentheses. So I remember to distribute that negative correctly. So in parentheses, negative 16t squared plus 100. Alright. Because I like working with addition more than I like working with subtraction, I'm just going to add the opposite, plus, plus, minus. So what happens to the 16t squared? They cancel, and I'm left with, well, no t squared, right? Because they're gone. Yeah, negative 40t. Is it minus 100 or plus 100? Plus 100, because you have plus 200 and you have minus 100. Yeah. So this is plus 100. And remember function notation? If I'm working with t's, that's where instead of saying y equals, it's good to just say f of t. F of t. Remember, that's the same thing as saying y. F of t. There we go. Equals. So
Outside of this function.
now it's an equation. Yeah. Now it's an equation in function notation, actually.
So the difference between
Yeah.
y
Yeah. Y equals, or f of t equals negative 40t plus 100. Great. So now it wants us, and this is the hard part. It wants us to, I want to know, the problem wants to know, what does the minus 40 mean, and what does the 100 mean? And that's really hard to think about what those mean. So I'm going to give you a few minutes to kind of analyze that. Maybe talk to someone around you, because it wants us to interpret the coefficient. So this is a coefficient, remember the number in front of the variable, and this is a coefficient, also called a constant, because it's by itself. So think about what those numbers represent. What I've learned growing up is that tables always help me. So I want to plug in these values. Remember, when in doubt, teach our doubt. Say that for a reason. We want to figure out what's happening. So I'm going to make this t and this f of t. So I want to know what's happening to the, because we said this was the distance in this f of t thing, the distance between the objects, right? So how far apart are they initially? Because this person starts out in this window here, this person starts out in this window here. How far apart are they initially? How are 0 to 100? They're 100 feet apart. So what does the 100 mean?
The initial distance.
Yeah, the initial distance, how far apart they are at the beginning. Does that make sense? So the 100, I'll just say initial distance. By the way, if I were to just say y equals negative 40x plus 100, what would you tell me this represents, the negative 40?
Distance.
The rate of change or the slope, right? Yeah. Don't overcomplicate it, right? It's a linear equation. It forms a line. This is my slope, negative 40. This is my y-intercept and my starting point. That's what that y-intercept is, that starting point. Remember we went down, we would go down 40 to the right one, down 40 to the right one. What does that 1 mean when I say to the right one, to the right one? Every second, right? So every second, what's happening to my distance? It decreases by 40. Yeah, exactly. So while I start out at 100 in the 0 second, in the first second, I take that and I decrease it by how much? 40. So what's my distance between the two objects? 60. Does that make sense? How I thought about that? So, tell me again, what does that minus 40 represent? Yeah, the decrease of the decrease in feet per second. The decrease of distance between the objects per second. Let's write that down. Decrease in feet between objects per second. All right. Any questions about that? Wow, I hope we can say it like that again for my next class. Okay. We're done. Any questions at all about the CNET? Tomorrow and Monday are very important lessons, so if you can't be here, definitely watch the video for tomorrow and Monday. We are starting a new table of contents. As soon as here we go.